In this video, we learn about genomic imprinting. Let us learn or start with the basic concept, that is what is imprinting. In general English, imprinting means to leave a mark. For example, if you're lying on a bed for a longer time, the blanket can leave a mark on your skin, on the face and all, right? So that is an imprint which has formed. Now let us apply this to the concept in genetics. It exactly means it means there is an epigenetic phenomenon where the expression of a gene depends on which parent it is inherited from. For example, you all know, like, we inherit genes from both mother and father. Now just observe this diagram here. On the top it is the DNA from the mother, and the lower down we have drawn it's a diagram from the, it's a gene which is come from the father. Now both the genes produce mRNA, which will finally contribute to protein formation. So that means both maternal and paternal alleles both are active, and they equally contribute to protein production, and that is called as non-imprinting, otherwise biallelic expression. Both the alleles of a particular gene are active. Now if I talk about paternal imprinting, so you just observe in this, what has happened is, in this case, the gene inherited from the father, it is marked here. Can you see that mark? So that is nothing but it is imprinted, right? That is why we call it as paternal imprinting. When paternal imprinting or a gene is marked, what happens is that gene will not express. Just remember that, okay? So the allele which has come from the mother, only that will be producing the protein. So when I tell paternal imprinting, always there is a misconception. Okay, when I tell paternal imprinting, it means paternal father's gene is what is expressed, but it is a misconception. Remember, it's actually the opposite. Whenever a imprinting or a marking of a gene happens, that will not be expressed, and that is called paternal imprinting. So in paternal imprinting, the protein is being produced only from the mother's DNA. Now similarly, in maternal imprinting, once the DNA which has come from the mother is marked, that will be silenced or it will be switched off. So the protein will not be produced. Only the paternal allele will start producing the protein. So just understand, in maternal imprinting, it is the father's gene which is active and producing the proteins. In paternal imprinting, the father's is silenced, so only the mother's gene will be producing the proteins. Now, so just to summarize, in genomic imprinting, remember, only one parental copy will be working, the other one will be silenced. So in majority of our genes are non-imprinted genes. Okay, it means both the alleles will be producing proteins in equal quantity. It will be equally contributing for protein production. But if I tell, in paternal imprinting, the father's gene is switched off. In maternal imprinting, mother's gene is switched off. Now remember, this mechanism is important for normal growth of brain and brain development actually. Some errors which can happen either in paternal imprinting and maternal imprinting, no, can lead to Prader-Willi syndrome and Angelman syndrome, which we'll be seeing in the next videos. What exactly are these syndromes?